Good morning to one and all. Myself Monish. I am second year BTech. I am here to tell about the topic design of 224 and 328 line decoder in Verilog. Design of 224 and 328 line decoder in Verilog. Introduction to line decoders. Line decoders are combinational circuits that convert binary inputs into one hot output. They are widely used in memory, address decoding, and data routing applications. This presentation discusses the design of 224 and 328 decoders in Verilog and basic concepts of decoders. A decoder takes n inputs bits and produces two cap n output lines. Only one output line is active at a time, corresponding to the input binary code. Only one output line is active at a time, corresponding to the input binary code. Decoders are fundamental building blocks in digital systems for selecting specific lines. Basic concepts of decoders. A decoder takes n input bits and produces two cap n output lines. Only one output line is active at a time, corresponding to the input binary code. Decoders are fundamental building blocks in digital systems for selecting specific lines. And 2 line decoder overview. The 224 decoder has two input lines and four output lines. It activates one output based on the 2-bit input combination. It is used for smaller section and decoding tasks within larger systems. Here we see the diagrams. A, B, and enable are the inputs of the 224 decoder and outputs Y0, Y1, Y2, Y3. Here you see the diagram also clearly mentioned in this slide. And truth table for 224 decoder. The inputs are labeled A and B with outputs D0, D1, D2, D3. As we see the previous diagram, 2 to 4 diagram, these Y0, Y1, Y2 are the outputs and A and B are the inputs and enable also. Only one output is high for each combination of inputs. For example, input 00 activates D0, 01 activates D1. Clearly observe. For example, input 00 activates D0, 01 activates D1, etc. Single decoder type test Moduco's hand positive single speed decoder, 2-speed decoder, 3-speed decoder. And next, Verilog implementation of 224 decoder. The modules uses input ports for A and B and output ports for D0 to D3. Assign statements or case statements can implement the decoding logic. The code ensures only one's output is high at any given time. Verilog implementation of 224 decoder. This is all about the module uses input ports for A and B and output ports D and D0 for D0 to D3. Assign statements or case statements can implement the decoding logic. The code ensures only one output is high at any given time. And next, designing 224 decoder in Verilog. Code example. An example uses a case statement inside and always block sensitive to inputs. The code assigns each output high based on the input combination. Default case ensures only one output is active when inputs are valid. The code assigns each output high based on the overview on the input combination. Default case ensures only one output is active when inputs are valid. And next, we see the 3 to 8 line decoder overview. The 3 to 8 decoder has 3 input lines and 8 output lines. It activates exactly one output line based on the 3-bit input. It extends the decoding capability for larger selection tasks. Here we see the logic diagram from 3 to 8 line decoder is clearly mentioned the diagram. 3 to 8 decoder inputs are A, B, and C, and outputs are D0, D1, D2, D3, D4, D5, D6, D7. And clearly mentioned that it activates exactly one output line based on the 3-bit input. It extends the coding capability for larger selections for tasks. And next, truth table for 3 to 8 decoder. Inputs are labeled A, B, C, and outputs D0, D7. Only the output corresponding to the binary input combination is high. For example, input 000 activates D0, 001 activates D1, and 010 activates D2, 010 activates D2, as so on. Only the output corresponding to the binary inputs combination is high. For example, input 000 activates D0, 001 activates D1, and so on. Here you see the circuit diagram also x2, x1, x0, and the triangle shaper is called as x2 bar and x1 bar and x0 bar, and the output lines y0, y1, y2, y3. Next, Verilog implementation of 3 to 8 decoder. The module takes 3 inputs and 8 more outputs. Logic can be implemented using assign statements or always blocks with case. The design ensures only one output line is high at a time. The module Verilog implementation of 3 to 8 decoder. The module takes 3 inputs and 8 outputs. Logic can be implemented using assign statements. Logic can be implemented using assign statements or always blocks with case. The design ensures only one output line is high at a time. Clearly observe that design ensures only one output line is high at a time. And designing 3 to 8 decoder in Verilog. Code example utilizes an always block triggered by input changes. The case statement map each 3-bit input to a specific output line. Utilizes an always block triggered by input changes. The case statement maps each 3-bit input to a specific output line. Default case ensures proper operations when inputs are valid. You see the diagram also, the logic diagram 3 to 8 decoder, and inputs are 3 and outputs are 8. Inputs are A, B, C, and outputs are D0, D1, D2, D3, D4, D5, D6, D7. Along and comparing 2 to 4 and 3 to 8 decoders. The main difference lies in the number of inputs and outputs. Both can be implemented using similar Verilog coding styles. The main difference lies in the number of inputs outputs. Both can be implemented using similar Verilog coding styles. Larger decoders like 3 to 8 require more extensive case statements or assign logic. Here we see the diagram also 2 to 4 decoder and 3 to 8 decoder. 2 to 4 has 2 inputs and 1 enable and 4 outputs, and 3 to 8 decoder has 3 inputs and 8 outputs D0, D1, D2, D3, D4, D5, D6. The main difference lies in the number of inputs and outputs. Both can be implemented using similar Verilog coding styles. Larger decoders like 3 to 8 require more extensive case statements or assign logic diagram. Applications of line decoders. Decoders are used in memory address decoding to select specific memory. Decoders are used in memory address decoding to select specific memory locations. They are essential in multiplexing and demultiplexing circuits. They are essential in multiplexing and demultiplexing circuits. Decoders facilitate control signals in complex digital systems. Decoders facilitate control signals in complex digital systems. Conclusion and further reading. Understand Understanding decoder design is crucial for system development. Extending to larger decoders follows similar design principles. For more details, refer to digital design textbooks and Verilog HTL resources. Here we see the code also. Module 2 to 4 decoder x comma y. Input 1 is to 0 x in output and 3 is to 0 y, where 1 comma 2 not gate g1 0 1 comma x of 0 not gate to 0 2 x of 1 and gate 3 y of 0 1 comma 2 and g4 y of 1 comma x of 0 comma 2 g5 y of 2 g1 x of 1 g6 y of 3 x of 0 comma x of 1. Assign output 0 is equal to x of 0 and x of 1. Assign output 1 x of 0 and x of 1. Assign output 2 is equal to x of 0 and x of 1 double quotes and assign out 3 x of 0 and x of 1 and in the end module and run the program. Understanding conclusion and further reading. Understanding decoder design is crucial for digital systems development. Extending to larger decoders follows similar design principles. You have for example you have the more details refer to digital design textbooks and Verilog HDL course. Applications of line decoders. Decoders are used in memory address decoding to select specific memory locations. They are essential in multiplexing and demultiplexing circuits. Decoders facilitate control signals in digital systems and applications. These are the applications of line decoders. Line decoders means 2 to 4 decoders and 3 to 8 decoders. 2 to 4 decoders has two inputs and 4 outputs and also 3 to 8 line decoders have also 3 inputs and 8 outputs as we see the diagram previous slides. And next, conclusion and further reading. Understanding decoder design is crucial for digital systems development. Extending to larger decoders follows similar design. Extending to larger decoding follows under for understanding decoder design is crucial for digital system development and extending to larger decoders follows similar design principles. For more details refer to digital design textbooks and Verilog Gestalt. So we see the code also. And thank you. This is all about my topic.